Let's look at lab number 9. This is going to be helpful for us as we work in chapter 5 with our logarithm and exponential type functions. So again, this is important information for success in chapter 5 in college algebra. When you get into this chapter, you're going to see a definition of a logarithm. Right now, we're just going to go through the manipulation of changing a logarithm equation to an exponential equation. You'll get more information on this as you cover section 5.2, 5.3, whatever it is. Anyway, right now we're just going to practice the manipulation. So you'll see the definition of a logarithm as y equal to log base a of x. It's important that you realize that a is a base. So this is what a logarithm looks like, y equal log base a of x. And he has an alternate personality, if you will. A logarithm can also be written in an exponent form. And the exponent form looks like this. X equal a to the y. A, again, is a base. So we want to take the arguments or the variables x, a, and y in the logarithm and convert them to this format in exponent form. X equal a to the y. We're going to also go the other way. We will take something in this exponent form, exponential form, and convert him to this logarithm form. They're equivalent, they say the same thing. We just want to be able to work with it in both formats. No need to worry about these constraints, but I had to put them in for the official definition of a logarithm. Two things we need to keep in mind when you get into chapter 5. You'll talk more about this, but there is a common logarithm where the base is 10. So log base 10 is called the common logarithm, and it's not written with the base in place like you see it here. A common logarithm is written as just logx. And if you pull up your calculator, this button right here, the log, is log base 10. There's another special logarithm called the natural logarithm. And the natural logarithm is log base e. So the base there is e. But when we write the natural logarithm, we do not write the base e. It's written as an lnx. This is not inx. This is lnx. Notice the base is not written down. It is understood to be e. It may, on your calculator, you will find that guy right here underneath the LOG button written as LN. To get familiar with this, I suggest that whenever you see the LOGX, I suggest that you write in the 10 so you remember it has an understood base of 10 there. And anytime you see the lnx or ln of any argument, I suggest that you write the en just so you can get familiar with what that ln represents, what its base actually is. So when I see an log with no base, I'm going to write in a 10. When I see an ln, there's no base, I'm going to write in an e. That's going to prove to be helpful as you're working in chapter 5. So now what we're going to do is we're going to practice converting these forms. So I'm going to write this definition down here. Y is equal to log base a of x, and that's equivalent to x equal a to the y. So we're going to practice converting some logarithms to exponentials. So right here, I have log base 3 of 9 equal to 2. I want to take this logarithm that is basically this form and rewrite him into the x equal a to the y form. So I want to rewrite him in x equal a to the y. So all I really need to do is represent who are my values for x, a, and y. Well, in the logarithm, the x value comes after the word log, and in this case, it's a 9. A is always the base, and this little number down here on your logarithm is your base, so in this case, it would be 3. And the y is the number that stands alone, which in this case is 2. So I'll put my 2 right here. So this logarithm in exponential form is 9 equal 3 squared. And it should make sense. 3 to the second power is 9, so I know that I converted it accurately. We want to do the same thing over here. We want to take this guy and put him in the form of x equal a to the y. So in this logarithm, which part is the x? It's the 1. Which part is the a? The base, 6. And which part is the y? It's the part that stands alone, which would be 0. So this is saying 6 to the 0 is equal to 1. Yep, we followed that. We looked at those rules earlier. Anything to the 0 power is 1. So that would make sense. Let's practice this next one. And remember, you can always pause the video, work it on your own, and then come back and see if you get it right. In this logarithm, the 1/4 is in the x position. So I'll have a 1/4 equal to, the a is the 4, it's the base, and the y is the number that stands alone. So I have x equal a to the y power. Does this make sense? It does, because remember, with negative exponents, you take the reciprocal. So 4 to the negative 1 would be 1/4. So when those logs convert, they should make sense. Okay, let's do the same thing here. I see the word log with no base. That tells me it has an understood base of 10, so I am going to write it in. Let's take this logarithm and convert him to x equal a to the y form. So what's in the x position is the x. So I'll have x equal, what's in the a position, or the base? It's that understood 10. And y is on the y side, so there's really nothing more than just rearranging these terms. So I'll have x equal a to the y is x equal 10 to the y. That's all. Nothing else to do with it. I see an ln, and when I see an ln, I automatically put a base e because it's not there, and this will help me remember. Let's take him, rearrange him, x equal a to the y. So the x is in the x position, a is the base, and I see that I wrote in the e, so there's my base, and then y is in the y position. So I'll have x equal e to the y. Remember, this is just practice for what you're going to do in Chapter 5. Let's look at ln e to the 5th equal to 5. I see an ln, so the base is e. So let's transform it into x equal a to the y. So e to the 5th is in the x position. The a, which is the base, is e. And y is the value that stands alone, e to the 5th. Oh, well, this guy, I can see I did it correct. It makes sense. E to the 5th power is equal to e to the 5th. Let's wrap this lab up and this video with going in the opposite direction. I want to now take an exponential format and change them to a log format. So let me just write what those were. y is equal to log base a of x, and then the exponent form is x equal a to the y. So now all the ones I'm going to be given are in this exponent form. Let's take the three values, put them in these three positions in the log form. I was hoping to get through this one without any technical difficulties, but let's see if we can wrap this up without any more. Okay, so I've got things in exponent form. So this is in the form of x equal a to the y. Let's change those around and write this as y equal log base a of x. So the y is in the -2, or the -2 is in the y position, so I'll have -2 equal log base. What's the base up here? Well, the 5, because it's raised to a power. So it'll be log base 5. And then what's in the x position? The x is in the 1/25 position. There we go. So we took an exponent, converted it to a log. So here, 2 cubed equal 8. This is a to the y equal to x. Let's rearrange them and have them look like this format. So the y is equal to 3. It's going to be log base, the base is 2, and the x value is 8. 3 equal to log base 2 of 8. This guy, what's he going to look like in y equal log base a of x format? What's in the y position? Actually, it's the letter y. What's in the base position? It's a b. And what's left over is the c. Let's take a look at this one. We've got a to the y equal x. Let's convert him to y equal log base a of x. So the y position is a 4. The base is a, which is 10, but remember for log base 10, we don't write it, but I'm just going to write it in, but realize he's understood. And the x value that I need to put in this position is over here, which is 10,000. So there is 10 to the 4th equal 10,000 in logarithm form. 4 equal log base 10 of 10,000. And finally, this guy is in the a to the y equal x format. And we're going to convert it. So the y position is a 0. The base is e. See that little guy? The a is my base, e. And what is in the x position, which is 1. Now, this would not be the official way to write it. Because it's log base e, we have to convert him to an ln. So log base e needs to be written as ln, same as the common logarithm. I'm not going to write the 10. I'm just going to write the 10,000. This should help you get through this lab assignment.